Question on definite integrals. The question is, find the value of the definite integral from 1 to e of natural log of x upon x dx. Options are being given. We need to find out the correct option here. Okay, so let's rewrite the given definite integral. That is, we have the definite integral from 1 to e of ln x, that is natural log of x upon x dx. Okay, so what we do here, we use, and let me put other colors, we use the substitution method here. Okay, let us suppose that u is equal to ln of natural log of x. We assume that this ln of x is equal to u. After that, what we do, we differentiate this u with respect to x. That means the derivative of du upon dx means the derivative of ln of x with respect to x. So the derivative of log of x is always equal to 1 upon x. Okay, now what we do, we cross multiply, that is x times du is equal to dx. Okay, so we have this equation and we have this equation here. What we do, we plug the value of u and dx in the given integral. That is, so we write the definite integral from 1 to e. In place of ln x, we write u. So let us write it here, u. Then we have divided by x. Let us divide it by x times dx, and dx is equal to this x times du. X times du. Okay, here some cancellation will happen. X and x gets cancelled. We are left the definite integral from 1 to e. E denotes the Euler's number, so we have u times du. Okay, now we can easily find out the integral of u. So the integral of u will be equal to u square upon 2, and we evaluate it from the lower limit and upper limit. Okay, now let us simply plug back the value of u, that is u is equal to ln of x, and here it is squared, so let us take square, divide by 2, and we evaluate this from lower limit and upper limit. That is, how do we evaluate it? First, we plug the value of x is equal to e, that is, we evaluate this integral, this expression or this term at e, then we subtract and evaluate it at the lower limit, that is 1. So we can write it like this: ln of, in place of x we have e whole square divided by 2, then we subtract and evaluate the same term at lower limit, which is 1. So in place of x we have this time 1, and we evaluate, we have square, then 2 divided by 2, and which will be equal to, now natural log of an Euler number is equal to 1. So that is ln e is equal to 1. So can we write 1 square divided by 2 minus log of natural log of 1 is equal to 0. So we get here 0 square divided by 2. That gives us the value of the definite integral comes out to be 1 upon 2 minus 0, which is equal to 1 upon 2. So the correct option should be B option. Okay, so here we simply apply what we call the substitution method. Okay, so we put numerator equal to u, then we differentiate u with respect to x. We get this expression, this relation, that is x times du is equal to dx. Then we plug the value of u and dx, that is, in place of dx we write x times du, and in place of ln x we write u, and then we solve this in terms of u. Then we plug the value of u back, that is u is equal to ln x in this expression. Then we evaluate it at upper limit and lower limit to get the required result. I hope I make myself clear in this video. Thank you.